Load and explore an AI dataset fast with pandas. By the end, you will have a tiny, runnable table in memory, a clear baseline model score, filtered comparisons under a token budget, and a per-task best model mapping. You will see how simple aggregation and filtering turn raw results into actionable signals. I'm Professor Pi, teaching AI foundations with Python from basics to advanced. Loading and exploring is where most projects live or die. Good exploration improves your average metric tracking and reveals which models deserve more compute. The trade-off is memory in interactivity. Pandas is excellent for hundreds of thousands of rows. But you will hit limits if you try to hold tens of millions in RAM without sampling or chunking. You get fast insights at small to medium scale. The intuition is simple. We load rows into a table. We compute averages and groupings to compare models. We add a token budget to simulate real constraints. This shines when you need quick answers and clear comparisons. The limitation is scale and real time. For huge corpora, you swap to chunking or a database. We will build a tiny in-memory results table, compute an overall baseline, rank models, apply a token budget, and pick the best model per task. First, let us construct the dataset in memory. This snippet constructs a tiny AI results table and reveals its shape and columns. It creates a pandas data frame from records, where data frame from records turns a list of tuples into a table with named columns. So no file access is needed. Each row contains a model identifier, a task label, a numeric evaluation score, and the token count used. The columns argument sets readable names which help later when we group or index. Finally, the snippet prints the data frame shape and the column order so you know how many rows you have and the exact names to reference in the following steps. Next, we will compute a simple performance baseline. This snippet computes the overall average MODI score across every row in the table. It extracts the score column into a variable called scores for clarity, and then calls the mean function on that pandas series, where mean returns the arithmetic average of the numeric values. The result is wrapped with round to 2 decimals, so the output is compact and easy to compare over versions of the dataset. That single printed number is a baseline. It answers the question, how do models do on average, before we start slicing by model or task. Now we will compare models by their average performance. This snippet ranks models by their mean score and highlights the current leader. It groups the table by the model column using group by, which collects rows for each model into a small subgroup, and then computes the mean of the score within each group. The result is a short mapping from model to average score. Sorting that mapping in descending order reveals the top performer. The snippet prints the top model and its rounded average, so you can immediately see who leads. This is the simplest aggregated comparison you will want to run after loading results. Next, we will apply a token budget and retest who wins. This snippet filters rows by a token budget and then finds the best model under that constraint. It sets a minimum token count as min tokens and builds a Boolean mask to keep only rows whose tokens meet or exceed that threshold. After filtering, it recomputes the mean score per model on this reduced set and sorts to find a leader under the budget. If you increase min tokens, you tighten the filter and reduce candidates, which can change who leads and might reduce sample sizes. Lowering min tokens broadens the pool and can restore previously excluded high performers. The printed output shows the budget, the leader, and its rounded mean score. Finally, we will select a winner for each task. This snippet picks the best model for each task and returns a tidy mapping you can use downstream. It groups rows by the task column, so each task is evaluated independently. Then it uses IDX max, which finds the index of the highest score inside each task group, to locate the winning row per task. The snippet selects the task and model columns, sorts by task for consistent order, and builds a plain Python dictionary that maps task names to the chosen model. The printed dictionary is a compact routing table you can plug into evaluation scripts or routing logic. Recap: load rows into a pandas data frame to get structure and column names. Use mean and group by to compare models and tasks. Beware scale. Pandas is great for interactive exploration, but not infinite RAM. Next step, scale this exact flow by adding timing and accuracy checks on larger corpora. Or swap the token budget for a cost budget and evaluate models under a monetary constraint. If AI Foundations in Python help, subscribe and watch the AI Foundations videos.